Tunaanza topic ya kwanza kwenye form 3 physics, na topic ya kwanza kwenye form 3 physics ni application of vectors. Application of vectors. Kwa hiyo kwenye form 3 physics we have many topics, and these topics zina uzito mbalimbali, lakini application of vectors ndo first topic. From there we have the second topic, which is friction. From there we'll have other topics in form 3 physics, ambazo tuna light, tuna thermal, na topic nyingine kama current, electricity tumesoma form 2, pia form 3 tunaisoma. Sasa kwenye hii topic ya application of vectors, kwanza unatakiwa ujue kuhusu scalar and vector quantities. Baada ya kujua kuhusu scalar and vector quantities, baadaye tutaenda kudiscuss kuhusu tunaidraw vipi vector, na finally tutaenda kuona different calculation kwenye hii topic ya application of vectors. Kwa hiyo kuna calculation nyingi tu ambazo tutazifanya kwenye hii topic ya application of vectors, na kama nilivyosema mwanzoni kwamba lazima uhakikishe una graph paper, una ruler, then una mathematical set ambayo iko full, mle ndani mna protractor ambazo tutakuwa tunazitumia katika kumeasure angle. Tutakuwa na measurement of angles, different angles ambazo tutakuwa tunazifanya, tutakuwa tuna measure kwa kutumia protractor. So kwenye hii topic ya application of vectors, kwanza utatakiwa ujue kuhusu scalar and vector, then baadaye tutaenda kusoma vector addition, ku-add one vector with another, ambayo kwenye vector addition tutakuwa tuna njia inaitwa graphical method, lakini pia baada ya hapo kuna njia nyingine mbili ambazo tutakuwa tunafanya vector addition, ambayo tutaenda kusoma triangular law pamoja na parallelogram law of vector addition. From there tutaenda ku-explain the concept of relative motion na kufanya calculations of relative velocity of two bodies. From there apply the concept of relative velocity in daily life. Tutaona what is the application of the concept of relative velocity in daily life, and then we will explain the concept of component of vector and how to resolve resolution of vector, and how to use the concept of vector resolution in solving different problems in physics. So tunachokisema ni kwamba kwenye form 1 physics ulisoma kuhusu physical quantities, na ulisoma fundamental physical quantities ambazo ni mass, length pamoja na time, na ukasoma other physical quantities. Lakini kwenye physics hii hapa ya form 3 tuna divide physical quantities into two major groups, the vectors and the scalars. So what are the vectors and what are the scalars? Tuone kwamba vector ni nini na scalar ni nini. So tunasema kwamba as we have already studied about physical quantities in form 1 physics, that we have many physical quantities used for measurement. Basically, physical quantities can be divided into two types, which are scalar and vector quantities. A scalar quantity is the type of physical quantity which have magnitude but no direction. Magnitude but no direction. So unavyokuwa define scalar quantity, cha msingi kabisa kukumbuka ni kwamba hii ni quantity inayokuwa na magnitude lakini haina direction. Tunavyosema magnitude tuna maana gani? Magnitude is the number that shows the value of quantity. Ni ile namba, kwa mfano tukisema 2 meters, ile 2 ndio magnitude. Meters maana yake ni SI unit. 10 kilogram, 10 ni magnitude. Kilogram ni SI unit. 30 centimeter, 30 ni magnitude. Each centimeter is SI unit. Then 150 degree, hii kwa mfano ni degree Celsius, 150 ni magnitude, while Celsius ni unit. So vector quantity, scalar quantity inakuwa na magnitude only, haina direction. Kwa mfano huwezi ukasema 10 kg north, hicho ni kitu ambacho kiwezekana. 10 kg is simply 10 kg. 2 meter unaweza kaeleza direction. 2 meter to where? 2 meter una measure direction fulani, una measure distance fulani. Distance haina direction, lakini displacement ina direction, because the displacement is the distance in a specific direction. Yani tunavyokuwa tunazungumza displacement, maana tunazungumzia distance in a specific direction. Distance in a specific direction is what you call displacement. Sasa tunavyokuwa tunazungumzia scalar quantity, inakuwa yenyewe ina magnitude only. A scalar quantity has magnitude only, where a vector quantity has both magnitude and direction. Kwa hiyo concept ya scalar quantity ina magnitude, has magnitude but no direction. So inakuwa ina namba peke yake, labda ni 2, ni 5, ni 10 bila kuwa direction. Lakini what is the vector quantity? Kwa sababu hapa tunatakiwa tuelewe what is scalar, what is vector. What is the vector quantity? A vector quantity is the type of physical quantity which have both magnitude and direction. The type of physical quantity which have both magnitude and direction. So magnitude kama nilivyosema ni namba ambayo inakuwa inaonyesha ukubwa wa kile kitu. Show the value, the number which show the value of the quantity. Lakini vector quantity inakuwa haina namba peke yake, pia inaonyesha direction. Kwa mfano rahisi ni kwamba mtu anapokuwa anaelezea motion of the car, let's say anaelezea motion of the car. For example, one may describe a car as traveling at 100 km/h north. 100 km/h. Kwa hiyo sasa, kama tunasema 100 km/h, then north is the direction. So the car was traveling at speed of 100 km/h. So speed was 100 km/h. Lakini in what direction? North direction. So a vector quantity inakuwa na two things, ina magnitude, then a vector quantity inakuwa na direction. Where a scalar quantity has only magnitude but no direction. That is the major difference between scalar and vector quantity. Scalar quantity inakuwa ina magnitude only, vector quantity ina magnitude pamoja na direction. So mtu akisema, for example, mtu akasema a car was traveling at 100 km/h north. Huyu mtu atakuwa ameeleza nini? Vector quantity. Kwa nini? This describes the speed of the car, ambayo ilikuwa ni 100 km/h, and the direction in which it is moving, which is north. So the speed of the car is 100 km/h, ambayo ni magnitude, and its direction is north. So combining all of these two, we get a vector quantity, which is velocity. So however, if we were only interested in the speed of the car, kama tungetaka only speed of the car, tustake direction yake. If we were only interested in the speed of the car and not the direction, we would simply say that the car is traveling at 100 km/h. So 100 km/h is simply the speed of the car, 100 km/h. But if we want to express the velocity of the car, we must say 100 km/h then north. So speed is the scalar quantity. Speed is the scalar quantity, while velocity is the vector quantity. In your Form 2 physics, you studied about speed and velocity. If you don't remember, no problem. Tunaweza tukawa tuna umbali from this point to this point. Let's say this is point A and this is my point B. So we have a certain distance here from point A up to point B. So mmoja anaweza kasema kwamba car ilikuwa na move kwenye motion kama hii hapa, then ikafika kwenye point B from A to B. Sasa hichi kutoka A kwenda B kwenye route kama hii hapa tunaita nini? Ni distance. Distance has no direction. Distance has no direction. Yenyewe ni inaenda tu kokote, kona, hiyo ni distance. Lakini if we are connecting point A and point B with a ruler, tukiziconnect point A na point B kwa ruler hapa, tukaconnect namna hii hapa. Hichi ambacho kiko kuanzia A kwenda B, tulicho connect kwa ruler, is called as displacement. So difference kati ya distance na displacement ni kwamba displacement has a direction, while distance has no direction. Hii displacement, kama tutachora compass direction kwenye point A, tukasema this is our north, then tukachora compass direction pia kwenye point hii A, tukasema kwamba tuna east pamoja na west. Manake this is our north in compass direction kwenye your form 1 geography. Manake hii tunaweza tukai-express kama labda yenyewe ni north east. Haijawa north east exactly kwa sababu north east itakiwa iwe hapa, lakini tunaweza kuexpress kama northeast. That means ninachomaanisha hapa ni kwamba displacement ina direction, lakini distance hatuwezi kusema direction yake ni kwa sababu gani? Mfika hapa imechange. So distance has no direction, while displacement has direction. Pia tunavyoenda kwenye speed na velocity. Speed tuna define from two. Speed is the rate of change of distance. So speed is the change of distance. Speed is the change of distance divided by change in time. Is the rate of change of distance. So distance because has no direction, pia speed itakuwa yenyewe ni scalar quantity. Speed itakuwa ina direction kwa sababu distance haina direction. So distance yenyewe ni scalar quantity, scalar, and even speed is the scalar quantity. Kwa tunaposema 100 km/h has no direction, is the scalar quantity. Lakini when we are talking of velocity from tu tumesoma kwenye motion ni straight line kwamba velocity is the rate of change of displacement. So itakuwa ni change in displacement divided by change in time. But we know displacement is the vector quantity. Why? Because it has specific direction. So displacement is the vector quantity, has both magnitude and direction, while velocity also will be the vector quantity kwa sababu nachukua displacement ambayo ina direction. So velocity also will be vector quantity. So tuna different physical quantities. Some of them they are vector and some of them they are scalar. Kwa mfano ukichukua quantity fulani, let's say unachukua quantity kama acceleration, then unataka kujua acceleration A, is this the vector or the scalar? Then from the formula, how do we get acceleration? Acceleration is the rate of change of velocity. So it's the change of velocity divided by change in time. Remember, velocity is the vector quantity. So if velocity is the vector quantity, tukichukua acceleration kwamba ni change in velocity divided by change in time, kwa sababu ni vector, acceleration nayo atakuwa nani? Atakuwa ni vector quantity. Kwa sababu velocity ina direction, maana yake tukichukua change in velocity divided by change in time, tutapata quantity ambayo pia nani? Ni vector. Kwa hiyo hapo utachukua ni u minus v divided by time, ambazo hizo zote ni vector quantity. Time yeye ni scalar. Time haina direction. Huwezi kusema 5 second north. 5 second is just 5 second. It is the scalar quantity. But the velocity is the vector quantity. Kwa mfano tukachukua quantity nyingine, let's say impulse or momentum. Impulse is the product of force times time. Force yenyewe, force F ni sawa na mass times acceleration. Mass is the scalar quantity. Mass yana direction. Huwezi kusema 10 kg north. Mass is the scalar quantity. But acceleration is the vector quantity. Kama ambavyo tumesema hapa juu, acceleration is the vector quantity. Why? It is because acceleration is the rate of change of velocity, and velocity is the vector quantity. Kwa acceleration nayo itakuwa vector quantity. Acceleration is vector quantity, mass ni scalar quantity. Force kwa sababu huyu hapa ni vector, force nayo itakuwa ni vector quantity. So ukichukua huyu force itakuwa ni vector quantity. Impulse ni force times time, na force ni vector quantity, so impulse itakuwa ni vector quantity. Kwa mfano linear momentum ambao ni mass times velocity. Momentum, remember mass is the scalar quantity while velocity is the vector quantity. So finally momentum will be the vector quantity. Kwa hiyo tuna different physical quantities ambazo tunaweza kuziweka. Some of them they are scalar and some of them they are vector quantities. So physical quantities zetu ni hizi hapa. Kwa mfano tuna force nimeielezea ni mass times acceleration. Acceleration is the vector quantity, force nayo itakuwa a vector quantity. Displacement ni vector quantity. Tuna velocity ni vector quantity, momentum ni vector quantity, acceleration ni vector quantity. Hizo zote nimeelezea. Tuna time. Time ni scalar quantity, haina direction. Distance haina direction. Speed, energy, temperature, hizi ni mifano tu za vector pamoja na scalar quantity. Kwa hiyo hapo tumeshamaliza concept inayoelezea vector and scalar quantity. The concept of vector and scalar quantity. In the next session tutaendelea pamoja kuhusu concept ya vector diagrams. How to draw vector diagrams, kwa sababu vector chenyewe ni labda velocity. So tunataka tuone velocity kwenye daftari tunaiandikaje tukitaka ku draw a diagram which represent velocity. So in the next session we will discuss about the vector diagrams.